Assalamualaikum and good morning. So today we are going to continue with lecture 5 of 5 for chapter 9 random variable, which is still in the third subtopic, which is continuous random variables. So the learning outcome for this lesson, at the end of the lesson, students should be able to calculate the expectation and variance of continuous random variable. So if you notice from the previous subtopic, which is a discrete random variable, we also have the expectation of variable x, random variable x. And then for the discrete, we need to multiply the x with its probability. And then we total up everything. But how about the four continuous random variables? So expectation or the expected value of a continuous random variable x with probability density function f of x is the mean of x and is denoted by mu or e of x. So the formula here, we still need to be multiply the x, the value of x with its probability, which is for the continuous random variable is function of fx, and we cannot total up everything. We need to integrate from the negative infinity to infinity respect to x. So expectation of any function of x, the same as the discrete random variable, we just have to multiply the function with the probability. So if x is a continuous random variable with probability density function fx, then the expectation of any function of x, let's say gx, is given by, so expectation of g of x equal to integrate from negative infinity to infinity of function gx multiplied with its probability, which is the fx respect to x. In particular, when gx is equal to x squared, then the expectation of x squared is equal to integration from negative infinity to infinity of x squared multiplied with fx respect to x. So let's do some example. Important properties of expectation. These properties is the same as the discrete random variable. It always true for both type of random variable. So expectation of a constant will be the constant itself, and expectation of ax, which is a is the coefficient of x, can be factorized out as the coefficient of expected of x. And expected of ax plus b is equal to a multiplied with expected of x plus b by using the first and the second properties. Let's do some example. Example 1, the probability density function of a continuous random variable x is defined as follows. So now we have the PDF of the function fx, and there are three functions that be defined in three different intervals, and other than these three intervals, there will be function 0. Now the question asks you to find the ex. What we need to do, we have to multiply x with the probability function. So because we have three intervals, three pieces of function, then we have to multiply each of the function with x following the interval. So the first interval from 0 to 1, we will integrate the x multiplied with its probability, which is 1 over 3x respect to x. The second interval from 1 to 3 is x multiplied with its probability, which is 1 over 3 respect to x. And the third interval from 3 to 4, multiply the x with the function, which is 1 over 3 of 4 minus x respect to x. Now what you need to do is to multiply first between the two function x and the probability. So what we have on the first one is actually 1 over 3 of x squared. So 1 over 3 is just, yes, the coefficient. Then we just have to integrate x squared, so we get x cubed over 3. So the 3 multiplied with 3, we get x cubed over 9. And then x multiply 1 over 3. 1 over 3 is just coefficient, so we integrate x, we get x squared over 2. So 2 multiplied by 3, we get x squared over 6. And the last one, we separate these two terms. So what we have is 4x over 3 minus x squared. So this 1 over 3 is just a coefficient outside. So we integrate 4x, we get x squared. 4x squared over 2, which is 2x squared, minus with 2x cubed over 3. So both multiply by 3, so we have 2x squared over 3 minus x cubed over 9. And then we just substitute the limits and we get the answer. The expected is equal to 2. Okay, example 2. A continuous random variable x has the following probability density function. The question asks you to find expected of x plus 1, expected of 2x, expected of 10 minus x, expected of 3x squared minus 5, and the last one, expected of y if y is equal to 3 minus 2x. So to find all of these, first thing you need to do is to find the expected of x for question A, B, and C. So the same as the previous example, the x must be multiplied with its function, its probability function from the following the limits. So we want to integrate x multiplied with 2 over 15 of x minus 1 from 2 to 5. So integrate both. What we will get? 2 over 15 is a coefficient we can take out. We need to integrate x squared minus x. So integrate x squared, we get x cubed over 3. But integrate x, we get x squared over 2. So now substitute the limits. We have the value of expected of x here is 19 over 5. And then answering the question A, B, and C, they ask you to find the expected of x plus 1. So it is the same as expected of x plus with 1. So it will be 19 over 5 plus 1, which is equal to 24 over 5. And then for question B, expected of 2x is equal to 2 of expected of x. So we get 2 of 19 over 5, which is equal to 38 over 5. And question C, expected of 10 minus x, it will be the same as 10 minus expected of x. So 10 minus 19 over 5, we get 31 over 5. But for question C, because the expectation of x squared in the question, so we need to find expected of x squared, which is integration of x squared multiplied with its probability from 2 to 5. So what is the function? The function is x minus 1, and the coefficient of 2 over 15 we take out. So it will be what? Here it should be integrate from 2 to 5 of x. Here we take out the 2x multiplied by x minus 1, and then the 2 over 15, it will be outside of it. Okay, so expand it, we get x cubed minus x squared. So integrate both, we get x to the power of 4 over 4 minus x cubed over 3. So substitute the limit, we will have the final answer expected of x squared is equal to 151 over 10. Okay, the next question D, they ask you to find expected of 3x squared minus 5. So this is the same as expected 3 multiplied by expected of x squared minus 5. So what is expected of x squared? We found it earlier, equal to 151 over 10. So 3 multiplied 151 over 10 minus 5. So we get the answer equal to 403 over 10. And then for question E, expected of y, we just replace y with 3 minus 2x. So we get expected of 3 minus 2 of expected of x. So expected of 3 is equal to 3 minus 2 of expected of x, which is equal to 19 over 5. So we get the answer equal to negative 23 over 5. So what you need to do is to find the expected of x and expected of y of x squared only, and then use the properties to find out for the others. The next concept is a variance of a function of continuous random variables. So it will be the same as the discrete, which is the variance of x is equal to expected of x squared minus expected of x all squared. So what you need to do here now is to find the expected of x squared and expected of x and sub the value into the formula of variance, and then you can find the standard deviation, which is the square root of variance. Okay, the important properties is the same as the discrete. It can be used for both random variables. So variance of a constant will be 0. Variance of ax is equal to a squared of variance x, and variance of ax plus b is equal to a squared of variance x. Okay. Now, example 3. X is a continuous random variable with its probability density function defined as follows. So fx is equal to this 3 piecewise function. They ask you to find the variance, calculate the variance and variance of 2x plus 1. So what you need to do? what is the formula of variance? Okay, the formula of variance is expected of x square minus expected of x all square. What you need to do is to find expected of x and expected of x square. So calculate as usual. So this is the answer of the expected of x, which is 1 over 2. So I don't think there will be problem because we just need to multiply the x with the first function from 0 to 1 over 2 and x multiply with the second function from 1 over 2 to 1. And then integrate, expand first and then integrate as usual and then substitute the limits and then you get the answer lah. So expected of x is equal to 1 over 2. And then the next one should be the expected of x square. So we have to multiply x square with its probability function. So the first one, the first interval from 0 to 1 over 2, x square should be multiplied with 4 over 3 of 1 minus x and plus with the integration from 1 over 2 to 1 of x square multiplied with its probability function, which is 4 over 3x respect to x. So what you need to do first, you just expand everything and then you get this coefficient 4 over 3 outside of the integral. So x squared multiplied by 1 is x squared and minus x squared multiplied by x is x cubed plus with 4 over 3 x cubed. So integrate both of these terms. So we get x cubed over 3 minus x power of 4 over 4. And for this one is x power of 4 over 4. And you sub the limit. So you will get the answer of expected x square is equal to 25 over 72. And now, the next thing is to find the variance by applying the value of expected of x and expected of x squared. So expected of x squared equal to 25 over 72 minus the expected of x, which is 1 over 2 square. We square the value of 1 over 2, so we will get the final answer 7 over 72 is the variance. And for question B, they ask you to find the variance of 2x plus 1. This is equivalent to 2 squared of variance x. So by using the properties, so 2 squared is 4. 4 multiplied with the variance, which is 7 over 72, we get 7 over 18 as the result. Okay. Now, for the next example, x is a continuous random variable with its probability density function fx. If integration of x squared fx dx is equal to 29, integration from negative infinity to infinity, and the variance 3x is equal to 36, find the mean of x. So how to find the mean of x? Okay, we can find the mean of x by using the formula of variance, because what we have here is actually the expected of x square. So expected of x square is given in the question, which is equal to the 29. And then variance 3x equal to 36 is equal to 3 squared of variance x. So 9 variance x is equal to, this is 9 variance x. So variance x is equal to 36 divided by 9, which is equal to 4. Now we have the variance of x, we have the expectation of x square. So by using the formula of variance, which is expected of x square minus expected of x all square. So from the above, we know variance is equal to 4 and sub the value of expected of x square equal to 29. So we get the expected of x here is equal to expected of x all square is equal to 25. And expected of x should be positive or negative 5. So both are true. Example 5. The continuous random variable x has probability density function fx given by fx equal to 3 over 4 of 1 plus x squared from 0 to 1. If expected of x equal to mu and the variance of x equal to sigma square, find the probability of absolute of x minus mu less than sigma. So what we need to do first, we need to find the expected of x, which is the mu, and we have to find the sigma, which is the square root of the variance. So how to find the expected? We use the formula of x multiplied by its probability. So by following the interval, it should be from 0 to 1 over function x multiplied by 3 over 4 of 1 plus x squared. So integrate this expression, what we get is 3 over 4 of x squared over 2 plus x to the power 4 over 4 from 0 to 1. And then we get the expected of x equal to 9 over 16, which is equal to 0.5625. And then we have found the mu. Now we need to find the sigma. So how to find the sigma? We need to find the variance. What is variance? It's expected of x square minus expected of x all square. So how to find the x factor of x square? We have the x factor of x already, right? So x square multiplied by its function, which is 3/4 of 1 plus x square. So what we get here, don't forget to expand first and then you can integrate as usual. So we have 3/4 of x square plus x power 4. Integrate x squared and x power 4, we get x power 3/3 plus x power 5/5. And sub the value, we get 2/5 for the expectation of x squared. So what is the variance? Variance is equal to 2/5 minus 9/60 square, which is equal to 0.0836. But the question gives you in the sigma only. So variance is sigma square. So sigma is equal to square root of 0.0836, which is equal to 0.2892. Now sub both values mu and sigma into the probability function that we need to find. So probability of absolute x minus mu less than sigma, it is equal to probability of x minus mu in between negative sigma and sigma. This is by applying the absolute inequality definition. And then x actually in between negative sigma plus mu and sigma plus mu. So sub both values sigma and mu into the probability. So we get x actually in between 0.2733 and 0.8517. So what we need to do to find the probability? We just have to integrate from the both interval, both limits. So we need to integrate the function, probability function 3/4 of 1 plus x squared from 0.2733 to 0.8517. Okay, so integrate as usual. The 3/4 is a constant. We just take out as a coefficient outside the integral and integrate 1 plus x squared. We get x plus x cubed over 3 and sub the limit. So finally, we will get the answer equal to, yes, 0.5832. So you guys can try on your own how to calculate and sub the value and check the answer. Is it the same as this answer? Okay, so that's the example 5. So what we need to do is to find the mu and the sigma first from the definition given in the questions. So I think that's all for the chapter 9, lecture 5. So we are done with chapter 9. So let's continue with lecture 10 after this. Okay, so fighting. Thank you.